following videos we're going to talk about circular motion. Again, circular motion is when the object actually goes in a circle or partial curve. It is not rotational, meaning it sits in place and spins as a basketball on your finger would, or a record spinning on a table, if you guys remember what records are. So circular motion. So we have this object that's going to be on the string here, 1 meter long. Here's the center, and we're swinging it, and as it goes past this point, this is sort of looking from the top view, it has a velocity going up. And what we want to know is finding out that velocity, how fast it's going, and also the force of tension. Now we need a couple other things in here, so we're going to say use that it goes around 4 times in 2 seconds. Okay, that's going to help us with the rotation, and then from there we can go on that. We also are going to need a mass, so I'm going to include the mass. Let's make it 2 kilograms just for a fairly easy number. So it could be any object as long as we know the size of it or the mass of it, and some of the other things like how fast it's going around. So it's a 1 meter, it's on a string or rope or wire. You're going to swing it around, do some circular motion. Alright, first thing, let's draw a free body diagram. We have the force of tension. Holding it this way, it's going that way with velocity, but the force of tension is going towards the center. It is actually going along the radius. And if we're going to put acceleration in there, which we are, we would also say that it is trying to accelerate radially or towards the center. Sometimes we call that centripetal acceleration or radial acceleration. So it is accelerating. There is a force, so we are going to use Newton's second law for circular motion, which becomes mv squared over r is the force, and that force is the force that's causing it to go in a circle, which in our situation is tension. Okay, so there we have the problem set up. What we need to do is calculate a few things though based on the information we're given. Alright, let's go on here with 4 times 2 seconds. That means it's going to make 4 revolutions. Where are we? Hello. It's going to make 4 revolutions in 2 seconds. Now, doing something per time is known as frequency, or how frequently something happens. So if we reduce that, the frequency actually comes out to be 2, and the units of frequency are hertz. That means how many rotations or cycles or events or laps or loops or times around per second. That reduces it to 2 per second. So once we have that, we could find period, and while we're here we'll just do that. Period is 1 over frequency. That comes out to be 0.5 seconds, and what period tells us is how long it takes the object to do one of those rotations. So that works out the equations. You could probably look at that and figure it out yourself. Also, moving on, what do we know here? With this, we can use the velocity, or find the velocity, which is 2 pi the radius over period, or 2 pi radius frequency. So if I solve that, I get 2 pi times a radius of 1 times a frequency of 2. Comes out to be, what's that, 4 pi, which is 12.6, something like that, meters per second. Alright, once we have velocity, we can go back up here to our equation for Newton's second law for rotational motion. The mass we put as 2 kilograms. The velocity is 12.6 squared. The radius is going to be 1 meter. It tells us what the force of tension is, which is going to be newtons. It's really telling us what the force of tension in the wire is. If I get a calculator real quick here, 12.6 times 12.6 equals times 2, 317, almost 318 newtons. Alright, divide by 4.5, that gives you about 70 some pounds. So it's pretty strong. You'd have to hold that if you want to swing that big object, but that is a 4 over a 4 pound object. So there's a quick circular motion using swinging something. Look for the next problem. We'll do a car going around the corner. Hope that helps out. Look for you soon.